Welcome to the ChemDoctor on a brilliant afternoon on a Sunday here in Phoenix, Arizona. And this particular presentation is going to go out to all those hardworking students who are starting into their finals week at various universities all across the world, especially to those guys who are doing electrochemistry as part of their final exam. And what I want to focus on today is how to balance a net ionic solution redox equation. All right, and I've already got a few videos that I've produced that are on my website under the link that is associated with oxidation reduction, and you'll also find some of these videos posted under the link that goes to chemical equations on the same website. And basically what I want to do here is just do more practice. And specifically what we're going to do is balance this net ionic solution redox equation by the basic method. Now, one of the things that comes up when I'm helping my own students with this is how you figure out the half reactions. So to do that, you've got to utilize a skill that quite frankly you should have already learned, and this involves establishing oxidation numbers for all of the elements that occur in the various components in these reactions, because what you need to figure out is what's being oxidized and what's being reduced. Now in an equation like this, it's somewhat easier to figure out because you're dealing with a metal. That would be the copper right here. In its metallic form, so it has its full complement of electrons, and then you can see on the right side of the arrow that it has been ionized and it has lost 2 electrons. So we can identify right away that in terms of this net ionic unbalanced equation, that the oxidation half reaction is going to be this one, like that. And I'll go ahead and we'll label it. So I'll put ox up here for oxidation. And then we look at the nitrate going to NO gas here, and this is most likely the reduction. So I'm going to go ahead and write that over here, but I'm going to prove it to you right now. So if we look at the nitrate first, and again, if you are foggy on the rules, where you're going to find them is going to be in an early chapter in your general chem book. It'll either be in chapter 3 or chapter 4 under the title of types of reactions, and in that chapter you'll find the section that provides the rules for establishing oxidation numbers. And one of those rules says that when we need to find, for example in nitrate, when we need to find the oxidation number of one of the elements that's in this compound, since this is a charged particle, what we're going to do is set an equation equal to the charge on the compound. So we're going to set this equal to -1. And then nitrogen can have a variety of different oxidation numbers, but oxygen, generally speaking, in most compounds, except in peroxides, is going to be -2. So since there's 3 of these, our little equation is going to be N minus 6 is equal to -1. So the nitrogen in this case is +5 in terms of the nitrate. Now in the NO gas, the oxygen again is going to be -2. So I'll go ahead and write that in here. All right, and then since there is no charge on this compound, we're going to set our little equation equal to 0. Again, the nitrogen is the unknown, and then we're going to be subtracting from that 2 because the charge on the oxygen is a -2. So the nitrogen in this case is equal to +2. That's the oxidation number on the N. So now you can see we go from the nitrogen being +5 to being +2, and the only way that could have happened was by gaining electrons. So I'm going to go ahead now and I'm going to rewrite my reduction half reaction over here. So this is how we identify the half reactions. You've got to assign oxidation numbers and then figure out what's being oxidized and what's being reduced. Now, in order to balance by the basic method, what we do first is balance actually by the acidic method. And this is a series of steps that you literally have to have committed to memory And you need to practice this a lot in order to get good at it. I described these steps in earlier videos, which I recommend that you watch before this particular one. And so I'm going to go ahead now and we're going to roll on the steps. So step number 1, okay, so this is my reduction. All right, now step number 1 is to split into the half reactions, which we've done. Step number 2 is to basically choose one or the other of the 2 half reactions to work with. And generally I use or work with the reductions step first. There's no reason for that. It's just a habit of mine and it doesn't make any difference. You could just as easily start with oxidation. All right, the third step is going to be to balance any non-O or non-H atoms. So we look at the nitrogens in this case and we see that they're 1-to-1 and there's no balancing required. Next, we look at the oxygens, and we're going to balance the oxygens by adding H2O. We see on the left side there are 3 oxygens, and on the right side there's 1 oxygen. So I'm going to add 2 H2Os to the right side of my equation. The next step is to balance the hydrogens using H+. Now, since we added waters to the right side of this equation, you can see that we now have 4 hydrogens over here. So we need to add 4 hydrogen ions to the left side of our equation. Whoops. To the left side of my equation. So it's going to be 4H plus NO3 minus going to NO plus 2 H2O. Now, after we've balanced the O's and the H's, we're ready to do charge balance. And we can see on the right side of my arrow here that the net charge is 0, but on the left side of my arrow, the net charge is +3. And how did I get the +3? Because 4 hydrogen ions is +4, and then this guy right here is -1. So 4 minus 1 is 3. So we need to reduce the left side of this equation to 0. And we're going to do that by adding electrons. So I'm going to add 3 electrons to the left side of my equation. And then I'm going to write my new equation, which is going to look like this now. Now, at the point where we have established the charge balance and we have balanced for all elements that are in this equation, we're now ready to move on to the other half reaction. Again, we run through the steps. We've already split into the half reaction. Next, we're going to balance the non-O elements and non-H. We can see here that we've got our coppers are 1-to-1. There are no oxygens, so there's no oxygen to balance. There are no hydrogens, so there's no hydrogen to balance. All we have to do here is balance the charge. The net charge on the left side here is 0. The net charge on the right is +2, so we're going to add 2 electrons to the right side of my equation. Now, the next step here is to inspect both equations, and specifically you want to look at the number of electrons. And you can see that in the copper half reaction that there are 2 electrons, and in the nitrate half reaction we have 3 electrons. We need to equalize these. So we're going to multiply the copper half reaction by 3, and we're going to multiply the nitrate half reaction by 2. Now when we do this, you're going to see what's going to happen. We're going to end up with 3 coppers like this and 6 electrons. Pay attention to that. And then on this one, again, we're going to end up with 6 electrons on the left side of the arrow. We're going to have 8 H pluses. We're going to have 2 NO3 minuses. We're going to have 2 NOs. And we're going to have 4 H2Os. Pay attention to the fact that we have 6 electrons here and we have 6 electrons in the copper half reaction, and they happen to be on opposite sides of the arrow. So this is good news because they're going to cancel. So now what I'm going to do is go ahead and rewrite the copper half reaction underneath the reduction half reaction, or the nitrate half reaction. And what you can see is we're going to have 3 coppers, and they are going to 3 copper plus 2s plus 6 electrons. I'm going to put an arrow, or put a line underneath these, because now we're going to add stuff up. And you can see that the electrons cancel out, and now we can write the balanced net ionic equation for the acidic portion of this. All right, and it's called acidic because of those hydrogen ions you can see there. If you were actually doing this in a titration, you would have some kind of a strong acid that would be added to this. All right, let's see. I'm going to make sure I don't mess up here. It's going to be 4H2O. So in the basic method, what we do is we run all the steps down through the acidic method, and now what we need to do is titrate or add hydroxide ion to both sides of this equation to cancel out all of the hydronium ion. That's this right here. So we're going to add 8 hydroxides to the right side, or excuse me, to the left side of my reaction. Just let me rewrite this. It's a lot of work, but I think it's a good idea to be rewriting the equation. It helps me avoid errors. All right, and then one place where students tend to make errors is right here. Make sure that you add your hydroxide to both sides of the equation. This is just like it's just like a math problem. Whatever you do to one side, you got to do it to the other. Now, I'm going to go ahead and circle. You can see that these 8 OH minuses and these 8 H pluses right here are going to produce 8 H2Os. And we're not done, because on the right side of this arrow, you can see we also have H2Os. So to finish this thing out, what we're going to do is cancel the 4 H2Os here, cancel 4 of the H2Os on this side, and the final equation, the final net ionic solution redox equation, is going to look like this. And sorry about my writing. I know that my coppers look like calciums. Just make sure that you're not in Zonerland about this, that you realize that I have bad writing sometimes. All right, and then our 8 hydroxides. So this is the final equation. Solution redox, it is a net ionic equation, so it does not contain any of the spectator ions. And with that, I'm going to go ahead and finish. And I'd like to thank the viewer for watching. And you can find more videos at www.chemdoctor.org. Thanks again for watching, and have a good Sunday afternoon.